All right, hey Morgan.
Howdy.
So it's gonna be the two-man Weekly Space Hangout again because
Dynamic duo.
with a dynamic duo, yeah. But because everyone is busy, people are traveling, people are writing books, so neither of us have books to write, so we thought we would.
I wish I was writing a book.
Yeah, really, you can write a book anytime you want, man.
I guess. I wish I had the nerve to write a book.
Oh, see, there's the problem. I give you permission, Morgan. Write a book. How's that coming? Well, hey everyone. My name is Fraser Cain. I'm the publisher of Universe Today, and this is your weekly space hangout for Friday, April 11th, 2014. Once again, I am on the road, on a remote location, but I will be heading back Monday, I think. So back in my normal studio. So this week we're going to do our best to try and cover some of the big stories. Probably won't be a regular length episode, although people do like the kind of back and forth. So we'll see where we get. We're going to give our review, an update on the latest Cosmos episode, possible discovery of an exomoon, just an update on that parachute, that rock that went past a parachuter, whether it was a meteorite or a rock, we're not sure. Just a big reminder about the lunar eclipse, the NRO launch, the SpaceX launch, and the radar problems they've been having, and that bright light on Mars. So as always, you can interact with us. The way to do that is to use the Q&A app, which is should be embedded in the YouTube video that you're watching right now. It says Fraser is answering questions. Click there, and if you do that, you can get access to where you can post a question, and you can watch the video and post your questions and talk to each other, and away we go. All right. Well, let's start. You know what? I want to start with Cosmos because I know we both watched Cosmos, the latest. Oh, we've been watching them all, and we
Yeah.
watched the latest one. And this one, episode 5, was about, I guess, the discovery of spectroscopy. I mean, pretty detailed stuff.
Yeah, I mean, it was really about how our world and how we interact with our world is shaped by light. And it took us hundreds of years to understand, the nature of the light that allows us to see and allows us to make observations about things like this mouse sitting on my desk to the stars that are as far away as we can see. But now that we've made those discoveries, they've become by far our most powerful tool in understanding the universe because there's really no other tool available. We can understand what we can see, and we can see in the parts of the electromagnetic spectrum that we understand. And as that grew, our ability to gain in knowledge grew. And it's only been in the last 50 or so years that we've been able to make full use of that. And you can see the remarkable discoveries we've made.
How did you like this episode compared to some of the others?
I really liked it. I think my favorite is probably still the evolution episode, but this would probably be my second favorite. I thought they did a much better job this week with using the CGI, the computer graphics, in a very educational way. I got a huge kick out of seeing the sound waves bounce around the organ chamber, and even larger kick seeing Neil talking at me with waves coming out of his mouth. It's a little disorienting. And I also really liked at the end when we saw the Manhattan skyline in all these different wavelengths, because it gives you a sense that really what we see and what we think of as reality is just a narrow band in a much larger sort of window to the universe. And if we could see in some of these other windows, we'd see a very different picture of the night sky, the day sky, and the universe at
What I
large.
thought was great too was that this is Neil deGrasse Tyson's specialty, right? He's an astrophysicist. He studied this while Carl Sagan was a planetary scientist. And so this is the stuff that Neil knows best, not the exploration of the planets and things like that. Although he can obviously speak on that. But so it was great to have sort of some of this material that I'm sure he really carefully picked through the script and was able to make sure that he felt comfortable about the way he could do it. And so then he was very comfortable and great in doing the presentation. So I thought it was great. And it was, I mean, just like prime time, they're discussing spectral lines and spectroscopy and all this kind of stuff on Fox television. That's just, we're living in a golden age.
I also really continue to like the stories that they're choosing to tell. I thought it was a really powerful story to point out at the beginning that for almost 1,000 years, the Arabic world, the Islamic world, was the center of science here on planet Earth. And that's something that's easy to forget these days when we often think of, Arabic countries as being maybe backwards or at least reticent towards science. We think of the Western world as Western medicine and Western science as pushing the boundaries. But for almost as long as that's been the case, even longer perhaps, it was the case that it was the Eastern world that was pushing the boundaries of science. And so we should be cognizant of the fact that what seems like sort of this dynasty right now could very easily change depending on the decisions that we make and our politicians make in the future.
Yeah, so I hope the rest will sort of follow on this vein. It felt a little less
preachy.
Yeah, preachy. I mean, I feel so bad because I am the preachiest of the preachy,
Yeah,
like
well.
I will attack pseudoscience and creationists and nonsense like crazy. So I definitely can't. I'm a total hypocrite when I say that it feels like the episodes are a little too preachy, like in the way there's a lot of kind of jabs at evolution deniers and things like that, because it's just, I don't know, it just feels like it cheapens the thing. So this one was just very much like, here's a wonderful thing about science. It's one of the most amazing things that we've discovered so far. It really is this, as you said, it's like the bedrock tool that scientists use to probe the cosmos, and here's how it works. And so I really enjoyed it. All right, let's move on. So let's talk about this. Let's talk about this bright light that was seen on Mars.
Yeah.
So you can follow the story. Now I know neither of us have actually blogged about it, but
no, I got a picture here. I think the picture from Curiosity. Can you see that?
Oh, let me see. Yeah. Let me.
All right. So this is a picture taken by Curiosity on the surface a few days ago.
Can you zoom in on the actual?
Yeah, if we zoom in, then on the corner here, this is as close as I can get. You can see this red box, and maybe in this red box you can see there's a little white light. Kind of looks like someone maybe is shining a flashlight at Curiosity.
Or like the glinting eye of a Martian?
Yeah, exactly. And so, like anything else that doesn't look exactly like we expect, people immediately started attributing this to aliens and saying, here we have, once again, NASA's already ignored that disappearing rock on Mars a few months ago. Here's one more instance of them refusing to acknowledge this obvious presence of alien life on the surface of another world, and how can NASA, be so irresponsible? Of course, it turns out that there's a much simpler explanation, which is that Curiosity contains not one but two cameras on its camera stock because it wants to take 3D pictures. When you take a 3D picture for The Hobbit, put two cameras next to each other, and they mimic your two eyes. Well, Curiosity does the same thing. So this is the right image. And if you look at the left image, you don't see this glint. And that means that it isn't really real, is the bottom line. It's probably something that required a very careful alignment with just one of the cameras. So this could be like a glint off a rock, for example. A very narrow glint that would hit one camera but wouldn't hit the other camera. If this was a flashlight or an alien's head or something like that, the breadth of the light would be large enough that it would hit both cameras.
Right, unless the Martian was just like shooting his low-powered laser beam just at one of Curiosity's
planes,
eyes.
they laser rovers, I guess.
Yeah.
The other thing it could be, and maybe the most likely thing it could be, is just a tiny blip in the sensor.
Yeah.
These things get hit by cosmic rays or just suffer from bad pixel readings once in a while. If you take out your camera phone and take a picture of anything, and if you zoom in at a white wall, you'll see some random green pixels and some random red pixels and some random blue pixels. And the same thing's true when you look at images from space. It's just that generally we're a lot better about controlling that than on a cheap camera phone or even like an SLR.
Yeah, and so and that's really it, like a cosmic ray. But I guess what really got people excited is just how well it is aligned with the horizon of that sort of mountain peak over there. So you can really see that there's like this ridge, and then there's that light. It's like right there on the ridge, and I guess that's what really got people excited. But I wonder if anyone's gone back through the older images, through the archives, and found lots of these kinds of little lights.
I mean, Curiosity and Spirit and Opportunity have returned, thousands, tens of thousands, maybe even hundreds of thousands of images. I mean, the Mars Reconnaissance Orbiter's returned at least that many again. So there's probably 1 million images of the surface of Mars. You could comb through those, and you'd find tons of these. And don't go do this, because we don't need any more of these controversies. But if you did, you would find these things are everywhere.
Yeah, absolutely. Good. Well, then that's that mystery solved right there. All right, let's move on. So let's deal with another kind of mystery, and this was this. We talked about this last week, about this parachutist who, I guess, captured a video of a rock passing, or a meteorite, and it was a suspected meteorite, because how could a rock fly past a parachutist up in the air? And I guess the original idea was that, at some point, people had tracked, like, you would have a meteorite, it would have entered the atmosphere, would have heated up, exploded, and then would have sort of hit terminal velocity as it came down through the air, and so it would have passed by the skydiver. And people had done analysis on the rate of the fall and where it had come, and it was definitely possible that it could have been a meteorite. But the internet has gone to work and done a lot more research, and it now really appears that it's just a rock that was folded up inside the canopy of the parachute when it was just folded on the ground. And apparently parachutists say this happens all the time, that you'll get a rock that's folded up in your parachute, and then as it deploys, the rock kind of tumbles out of the parachute and falls down beside you.
Yeah, well, you can imagine it doesn't even have to tumble. You deploy that parachute, it's going to snap out, snap taut, and that could really eject a rock that was in a fold of that parachute, at quite some velocity. And from first to last, this has been carried out really well. The parachutist didn't go out and claim that he'd seen a meteorite. He took it to some scientists, who then took 2 years to look at the video, to look for the rock, and eventually putting it out there saying, we don't really know. We think this could be a meteorite, but we're looking for more input. And lots of people gave their input, and we saw some compelling arguments that it could go either way. And I think sort of the final argument I saw came from a NASA scientist who said it's either like a 2-centimeter rock that passed relatively close to the skydiver, or it's like a 20-centimeter meteorite that passed somewhat farther away. But meteorites hit the Earth far less frequently than skydivers pack rocks into their parachutes, and therefore it's much more likely to have been a packed rock than a parachute, although he couldn't really rule it out one way or the other.
Yeah, and I think I think you're exactly right. This is precisely how science has to work. Is that somebody says, "I just saw a thing. I don't know what it is. Can somebody please find out?" And then the crowd goes to work. They come up with theories. They test them out, and they come up with what they think is the consensus of the evidence. Same method, whether we're talking about rocks flying past skydivers, glints of Martian eyes, or
what it really reminds me of. Yeah, what it really reminds me of is the faster than light neutrinos at the LHC. There's another example where they came out and said, we don't think this is true, but this is what we're seeing. And some people took that and ran with it as, oh my God, general relativity is completely broken. And everybody else took their time and studied the data and came up with alternative explanations, and eventually we came to a consensus about why these neutrinos weren't flying faster than the speed of light. And so it's difficult these days, because science needs to be public and it needs to be collaborative. But bloggers also need to get ad hits. And
what?
So people...
No. That has nothing to do with this.
People will take, what's good, sound scientific action and spin it into a story that maybe is a little exaggerated. And, certainly you and I would never try to do that. But there are plenty of people out there who are looking for links and nothing else. And that makes it difficult as a scientist to draw the line, when are you public and when are you not? And both this and the LHC, these are examples where, this is not a super contentious issue. But if you're like a climate scientist again, you have these readings that you don't really believe, but you feel other people need to see them. It's a lot more difficult to judge, when to put that out for people to see, because, the ire of the world is going to come down on you. And that's unfortunate, because the more things that are public in science, the better science can operate.
Well, we definitely do jump on board whenever these things happen, but we tend to come at it from a skeptical point of view. And so, as the publisher of a news organization, I can sort of verify that, taking the skeptical point of view, you don't need to breathlessly repeat what everybody's saying.
They deserve to be covered. It just deserves to be covered from the right angle.
Yeah, exactly. And so it's still, you can still get lots of page views on your articles without having to necessarily hype things up and make them sound fake. So, all right, well, let's move on. So this is a story that you worked on, which was that there was a possible exomoon discovered.
Yeah, so, for the last 15 or 20 years now, we've been discovering exoplanets. But planets aren't the only thing in our solar system. We have asteroids and comets, and we also have moons. And there's probably about 200 moons around the major objects in our solar system. We've discovered about 150, 160, depending on what you count as a moon and what you count as a major solar system object. But there's more out there. There's probably some around Uranus. There's some around Neptune. So we expect them to be around the planets, the thousands of planets we've now discovered out there around the other stars. But the trick is that finding a planet's difficult enough. Finding a much smaller moon is an even more challenging problem. And up till this week, we hadn't had any instances where we thought this had happened. People have been combing through Kepler data looking for the signatures of moons with no luck. And so what happened, I guess, in this instance is we kind of went back to an old school technique for discovering exoplanets. And that's called gravitational microlensing. And this is old school because it's not repeatable, it's very lucky, you can't really plan for these to happen. So what does happen is astronomers, for some reason, are looking at a patch of sky, and they'll see a star temporarily brighten and then dim again. And what's happening is there's a star or a planet or something that's passing just right in front of that background star, so that its gravity bends more of that light towards us. It acts as a gravitational lens or a magnifier. It makes that star look brighter. But that only happens when the star, this middle object, and us are in a perfect alignment. And these things tend to last for seconds or at most minutes. And once they happen, you can never look at them again, because you don't normally see this intermediate object.
Yeah, that's the real tragedy of these observations, that when you get the gravitational microlensing, it's this one-time alignment between these objects, and then they're never going to line up again. And you're never going to get a situation where the foreground object is going to ever line up with another object in your sky. Like, that's it. You had your one chance. Yeah. That's it.
The good news is that the upside to this is that microlensing is the most sensitive technique available. And so if you have one object orbiting another, whether that's a star or a planet orbiting a star, or a moon orbiting a planet, you'll see that signature as two brightenings. A big brightening from the big object, and then a tiny additional brightening from the little object. And by comparing the sizes of those brightenings, you can get an estimate for the relative size of these objects. But if you don't know how far away they are, that's kind of all you know. So they found this object, or this pair of objects, and they said that one is I think it was 1,800 times larger than the other by mass. And so that could either be like a planet the size of, or a star the size of the sun with a planet the size of Neptune, or that could be a rogue planet the size of Jupiter with a moon about the size of the Earth.
Wow.
Or a little smaller. And the only way to differentiate between those is to know how far away they are. But the only way to get that is to observe the object a second time. And especially if it's a rogue planet, which puts off basically no light, there's just no way to ever find that object again. So we're left with, a what if, basically. Maybe we've just seen our first exomoon, maybe not. And we'll probably see some more of these events as telescopes become more sensitive. But again, we'll probably be unsure if we're seeing a planet and a moon or a star and a planet.
Yeah, gravitational microlensing is one field that actually the amateurs can get involved in. So if you've got a pretty good rig, there's whole groups of amateurs who are involved in these networks and they'll get alerts when there's a potential microlensing event coming up, and people can get involved in the observations. And sometimes amateurs are the ones that contribute or even discover these extrasolar planets, and I guess, in this case, the chances are that you can actually discover an exomoon, which would be mind-bending.
Yeah, I mean, there's just so much sky out there, and so few astronomers and astronomical grade telescopes, professional grade telescopes, that at any given time we're looking at the slimmest fraction of the sky, but the tens or hundreds of thousands of people out there every night with their telescopes are seeing a lot more of the sky. And since these events are essentially random, you have just as good, if not better, chance than a professional to detect one of these things happening.
Yeah. All right. Well, let's move on. Well, that's really cool. So now, I just want to give a reminder, which is that there's going to be a lunar eclipse in just a couple of days now. So this is going to be a total lunar eclipse. And we mentioned this last week, and Dave went into the details and all the blood moon and all that kind of stuff. But just to sort of make sure you know what's going on. So it's going to be happening at 4:37 in the morning, Universal Time, but it's going to be 12:37 a.m. Eastern Daylight Time on the 15th. And so for those of us on the West Coast, it's going to be on the 14th, the night of the 14th, at around 9:30, which is perfect. That is the perfect eclipse. So if you have never seen a total lunar eclipse, this is your chance. If you live in North America, which I know most of our viewers do, you're going to want to head out anywhere between 9 o'clock and 9 o'clock if you're on the West Coast, midnight if you're on the East Coast, and then stick around for a few hours and watch bites get taken out of the moon, and then it'll turn blood red, and then bites will come back into the moon, and then it will be clear. And it's absolutely one of my favorite events to see. And what's great about this is you don't need any kind of special protective gear. You're just looking at the moon, and the moon turns red, and it's great to kind of gather together.
Hours. You don't have to get out there for the exact minute like with a solar eclipse.
Yeah, totally. You can just
look
go
out sometime at night, and you'll see it.
And you'll see it happening, like, wow. And it looks very different from the crescent moon, from any other shape of the moon. Like, it's clearly a chomp is getting taken out of it. So if you've never seen a lunar eclipse, this is, like, we haven't had one of these in years now, probably 3 or 4 years, that we've had a nice lunar eclipse visible from North America in the evening. So this is your chance. So remember, you're going to want to go out there on the 14th, the night of the 14th, or the morning of the 15th, and watch it. Have you seen a bunch of lunar eclipses?
I think I've only seen like 1 or 2 in my life. Yeah, like you said, total lunar eclipses aren't terribly common. I think this is an unusual year where we're going to have 2 or 3 in the same year. And unfortunately, I've spent most of my life living in places that are cloudy for a lot of time, and so I've missed out on plenty of possible eclipses in the past.
I'm sure, yeah. Where I live, west coast of Canada, this is like the cloudy, rainy time, so I'm sure I won't get a chance.
I'm fingers crossed this time that I'll get it.
Yeah, absolutely. Okay, great. Well, let's move on. So I think the last story we're going to cover, and then we'll answer some questions, is sort of the series of launches and the radar problems that have been happening with NASA. So do you want to tell people what's going on?
Yeah, so a couple of weeks ago, 2 launches were supposed to take place out of Cape Canaveral. The first was from the NRO, which is the National Reconnaissance Office, and they basically launched spy satellites. So we actually have no idea what they're launching. We just presume that they're spy satellites for the U.S. and for NATO. But they're there. They're, I guess, important if you like national security. More interesting to
people, yeah.
More interesting to the rest of us might be the SpaceX launch, and this is just going to be SpaceX's, I think, 4th trip delivering equipment supplies to the International Space Station. But what's cool is, you might remember a month or so ago I mentioned that they've bolted landing legs on the side of this SpaceX rocket. And although they're not going to actually try to land this one, they're going to deploy the legs once they've launched and released the Dragon capsule and try to sort of mimic a landing procedure by hovering, over the ocean. And they're setting expectations pretty low here. I think they're hoping to get the legs out. I think they're hoping to measure how the legs affect the stability of the rocket, and they're hoping to restart the engine using that stability. And then as we go forward to future launches, they're hoping to practice hovering over the ocean surface and eventually then hovering over landing pads and basically reusing these Falcon rockets. The problem was, yeah, go ahead.
Oh, Eric Charlin just posted that there's going to be launch for Monday at 4:58 Eastern Time. Live webcast is going to start at 4:20 Eastern Time.
That's PM?
Yeah.
Yeah.
Yeah, PM.
Yeah, so that'll be on NASA.tv.
Yeah.
Always good fun to watch those launches. But they were supposed to happen, I think it was maybe March 30th. That was supposed to be the launch date for the SpaceX capsule. And that didn't happen. And that was because the major tracking radar on the East Coast, the southern East Coast of the U.S., caught on fire. There's an electrical short somewhere in the radar, and it basically burned down. And this radar is critical because this is how we monitor the trajectory of the rockets once they're launched off of Cape Canaveral. NASA TV points their cameras at them, and we can sort of see where they're going, but the radar gives the precise information. And this is important because, although it happens extremely infrequently these days, once in a while a rocket will veer off course. One of its engines gets stuck or shuts down, and it starts veering over the relatively populated, Florida coast. Coming after Dave, basically.
Yeah.
And once that happens, they have to be able to self-destruct the rocket, at a moment's notice. And so having this giant working radar is an absolutely mission-critical requirement, and so they had to postpone all launches of any size from basically the southern half of the United States until they could get this radar back online. And so what they've done is they've made a combination of repairs to the existing radar, and they've brought sort of a backup secondary radar online as well. And that made them comfortable enough to launch the NRO rocket yesterday, and that lifted off successfully yesterday afternoon, and is presumably now, watching our houses right now. And that gives them confidence in the SpaceX launch that should happen then on Monday, and deliver, hopefully peace pipes to the astronauts on the space station.
Right. Very cool. Okay, cool. Well, I'm going to take some comments and questions. I think that was all the stories we wanted to cover this week. So I'm going to take some comments and questions here. Dale Jacobs notes that Nancy posted an article about the parachutist that must have packed a rock up when folding his chute. So yeah, so we just posted that. Nancy just posted that article to Universe Today and goes into the details and gets quotes from the original researchers who were trying to figure this out. Rich Hayward says, well, maybe the Martian was looking for his jelly donut. So jelly donut, of course, was that rock that was there on the surface of Mars, and people were wondering what that was, and clearly that was, the glinty-eyed Martian was looking for the jelly donut. All right. Yeah, okay, so Dale Jacobs notes that a classic example, and this is back to sort of science being done right, is Pons and Fleischmann's cold fusion claim. And we did an episode on cold fusion in Astronomy Cast and sort of covered that. And, that was a good example, I think, of not necessarily the scientists, but other people as well, really trying to push people to go public with what could be a very big piece of information, as opposed to going through the right channels and going and getting it peer-reviewed and so on. Pons and Fleischmann went public, but it sounds like it wasn't necessarily their choice. There's a lot of pressure coming.
There's enormous pressure from all sides. Scientists want to show that they're making progress so that the funding agencies will continue to, support them. And the funding agencies like NASA or the NSF or the National Institutes of Health want to show that progress is made so that Congress and the taxpayers will continue to support them. And the media and taxpayers want to see progress because they want to know that good things are happening in the world. And so, there's pressure that comes on you from all sides pretty much at all times to say something cool that's happening, even if you're not 100% sure about it. And, as the magnitude of these discoveries ratchets up, whether it's cold fusion or, a cure for HIV or cancer or malaria or what have you, we have to be more and more careful about what we say and when we say it, because you don't get two chances to roll out an announcement, and you want to get it right the first time, and you want people to take you seriously the first time. And if you're the kind of person who's 5 times announced that you've solved cold fusion, if you really have solved it in the 6th time, it's going to be a lot harder to get people to write stories and review your papers.
Yeah, I mean, you think about all the times we've heard that cancer has been cured. And it's just like it has not. So
I mean, you're jaded now. You don't believe it.
Yeah.
And so when eventually, someone does cure a kind of cancer, it's going to take a lot more, to convince people, and they're going to have to work harder to get the attention for it because so many people have burned us in the past, and that's unfortunate.
Okay, so Hugo Burnham says, I think I read that 35% of MSL images have cosmic ray strikes on them before cleanup. So there you go. So tons of cosmic rays. Now, I don't know that statistic, so.
Yeah, I mean that's about right for any, and Mars does have a slight atmosphere that's going to absorb a few of those. You look out in space and you look at raw images from Hubble or Cassini or something like that, you can see images where there's just cosmic ray strikes everywhere.
Yeah.
There's cosmic rays going through your body right now. As distressing as that is to think about, and they're everywhere, and they're unavoidable, and we put a lot of effort into correcting for them, so that we don't have to see them in our final images. But they can look like shooting stars, they can look like comets, they can look like moons, they can look like Martians. They're it's a puzzling thing, and once you know they're there, you're like, oh yeah, that's probably a cosmic ray. But if you don't know it, you're like, oh my God, there's like this giant comet coming down into the Earth's atmosphere, or I've discovered an alien on Mars, or I found the 3rd largest moon of Jupiter, and you just have to take that with a grain of salt.
Okay, well, I think those are all the big questions we've got here. Hugo Burnham wants to know, what are the chances of discovering an exomoon orbiting an exoplanet that is orbiting a multiple star system?
I mean, the chances that exists are, like 100%. Somewhere out there in the universe that exists.
Yeah, absolutely. If you
so let's get that out of the way first. If you can imagine a planetary configuration, and we haven't found it yet, we'll probably find it soon, because we found some truly absurd and previously unimaginable configurations. I just saw your video on
there's 17
worlds.
Circumbinary systems out there with planets.
The trick is that every time you add something like that, you add complexity. And so just 2 stars orbiting each other with planets gets brighter and dimmer and brighter and dimmer as the stars pass in front and behind of each other. That's the same way we look for planets using Kepler. You add a planet into that mix, now you have 3 peaks and dips going on. You add a moon into that mix, now you have not only do you have 4 peaks and dips, but you have 4 peaks and dips of different sizes, of which the more interesting ones, the planet and the moon, are by far the smallest. And so, we will find those. It's just a question of whether Gaia does it in the next couple of years, or whether it's going to take something like the terrestrial planet finder, or even a further generation of technology to resolve those things. But you can be sure that they're out there, and you can be assured that we'll find them. It's just a question of how long that might take.
Well, we've been talking about people are looking for a real Tatooine, and I guess people are going to be looking for a real Endor, right?
Yeah, I mean, hopefully there's not a real Death Star in orbit.
Yeah, if you
orbit about it.
Right? Yeah, you could detect the Death Star orbiting the Endor, orbiting the planet, orbiting this. Yeah,
see that green laser coming towards us.
Yeah,
and,
that's no moon.
Sound the alarm.
That's a space station. Cool. So why don't we wrap this up? So Morgan, where do people find out more about you?
Yeah. So the website is cosmicchatter.org. And you can follow us on Twitter at @cosmic_chatter. I think you can also follow me on Twitter at Morgan Renberg, although I'm not particularly active in tweeting on that account. So definitely drop me a line, ask a question, just say hi. I love to hear from people.
And were you planning to stick around after and hang out in the space
Yep. So I'll be at this Google Plus space community for the next hour or two at least. We'll see how questions go. So if you have any other questions, space related or not, I suppose, I'll be happy to take a crack at answering them. And if I don't know, I'll try to find someone who does.
Fantastic. All right. And once again, I'm Fraser Cain, publisher of Universe Today, and you can watch, if you haven't already, subscribe to this channel, this YouTube channel that you're watching this on, and we will, and you'll get lots more good stuff almost every day. So, all right. Well, thanks everyone for watching. Thanks Morgan for showing up. Really appreciate it, and we'll see you all next week.
About how our world and how we interact with our world is shaped by light, and it took us hundreds of years to understand, the nature of the light that allows us to see and allows us to make observations about things like this mouse sitting on my desk to the stars that are as far away as we can see. But now that we've made those discoveries, they've become by far our most powerful tool in understanding the universe, because there's really no other tool available. We can understand what we can see, and we can see in the parts of the electromagnetic spectrum that we understand, and as that grew, our ability to gain in knowledge grew, and it's only been in the last 50 or so years that we've been able to make full use of that, and you can see the remarkable discoveries we've made.
How did you like this episode compared to some of the others?
I really liked it. I think my favorite is probably still the evolution episode, but this would probably be my second favorite. I thought they did a much better job this week with using the CGI, the computer graphics, in a very educational way. I got a huge kick out of seeing the sound waves bounce around.
Great, and it was, just like prime time. They're discussing, spectral lines and spectroscopy and all this kind of stuff on, Fox television. That's just, we're living in a golden age.
I also really continue to like the stories that they're choosing to tell. I thought it was a really powerful story to point out at the beginning that for almost 1,000 years, the Arabic world, the Islamic world, was the center of science here on planet Earth. And that's something that's easy to forget these days, when we often think of Arabic countries as being maybe backwards or at least reticent towards science. We think of the Western world as Western medicine and Western science as pushing the boundaries. But for almost as long as that's been the case, even longer perhaps, it was the case that it was the Eastern world that was pushing the boundaries of science. And so we should be cognizant of the fact that what seems like sort of this dynasty right now could very easily change depending on the decisions that we make and our politicians make in the future.
Yeah, so I hope the rest will sort of follow on this vein. It felt a little less all right, hey Morgan.
Howdy.
So it's going to be the two-man Weekly Space Hangout again, because
dynamic duo.
The dynamic duo, yeah. But because everyone is busy, people are traveling, people are writing books, so neither of us have books to write, so we thought we would.
I wish I was writing a book.
Yeah, really? You can write a book anytime you want, man.
I guess. I wish I had the nerve to write a book.
Oh, see, there's the problem. I give you permission, Morgan. Write a book. How's that coming? Well, hey, everyone. My name is Fraser Cain. I'm the publisher of Universe Today. And this is your Weekly Space Hangout for Friday, April 11th, 2014. Once again, I am on the road, on a remote location. But I will be heading back Monday, I think. So back in my normal studio. But so this week we're going to do our best to try and cover some of the big stories. Probably won't be a regular length episode, although people do like the kind of back and forth, so we'll see where we get. We're going to
the organ chamber, and even larger kick seeing Neil talking at me with waves coming out of his mouth. Is a little disorienting. And I also really liked at the end when we saw the Manhattan skyline in all these different wavelengths, because it gives you a sense that really what we see and what we think of as reality is just a narrow band in a much larger sort of window to the universe. And if we could see in some of these other windows, we'd see a very different picture of the night sky, the day sky, and the universe.
What I thought was great too was that this is Neil deGrasse Tyson's specialty, right? He's an astrophysicist. He studied this, while Carl Sagan was a planetary scientist. And so this is the stuff that Neil knows best, not the exploration of the planets and things like that. Although he can obviously speak on that. But so it was great to have sort of some of this material that I'm sure he really carefully picked through the script and was able to make sure that he felt comfortable about the way he could do it. And so then he was very comfortable and great in doing the presentation. So I thought we're going to give our review, an update on the latest Cosmos episode, possible discovery of an exomoon, just an update on that parachute, that rock that went past a parachuter, whether it was a meteorite or a rock, we're not sure. Just a big reminder about the lunar eclipse, the NRO launch, the SpaceX launch, and the radar problems they've been having, and that bright light on Mars. So as always, you can interact with us. The way to do that is to use the Q&A app, which is should be embedded in the YouTube video that you're watching right now. It says Fraser is answering questions. Click there, and if you do that, you can get access to where you can post a question, and you can watch the video, post your questions, and talk to each other, and away we go. All right. Well, let's start. You know what? I want to start with Cosmos because I know we both watched Cosmos, the latest. Oh, we've been watching them all, and we watched the latest one. And this one, episode 5, was about, I guess, the discovery of spectroscopy. I mean, pretty detailed stuff.
Yeah, I mean, it was really